1 second. Just setting up my screen. Good morning. How are you? Hi, Dilshan. How are you? What's your major, Dilshan?
Oh, it's biology.
And okay, where are you heading afterwards?
Physician assistant.
Cool, very good. How much longer?
I'm sorry.
How much longer are you?
Oh, I still have about 2.5 years at Fresno State.
Oh, okay. Cool. You know, what is that on your wall in the back? What does it say?
Oh, it says you know the vibes.
You know the vibes. Okay. All right. Hi, Danielle. Hi, Trevin. Hi, Jamela. Hi, Desiree. Hi, Fernando.
Good morning. Get off.
Oh, look at that, man.
Yeah,
What kind of dog is that?
she's a Belgian Malinois mixed with Husky.
Extremely adorable.
Thank you. She's
How-
wild.
How old is she?
She's a year and a half.
Oh, pretty young.
Thank you.
Yeah. Hi,
Okay.
Karen. Hi,
Give it.
Fernando.
Hey, come here.
Thanks for keeping your cameras on. Appreciate it. It wakes me up in the morning. Hey, good morning, Shannon. How are you? What are you drinking?
Tired.
Tired? Did you work last night?
I mean yesterday. I work in the mornings.
Oh, okay. Hi, Queenie. Hi, Matthew. I'm just reading the names off of the screen.
Good morning, Professor.
Good morning. How are you?
I'm here. How are you?
What's your major? I'm just trying to have like some conversation with you guys.
I'm an animal science major.
Cool. What's your favorite animal?
Honestly, I love cats.
You like cats. That's okay. You don't have to be apologetic. Hey, Matthew. Are you going to be the cat doctor? You can be a cat whisperer. Is Monday holiday? Even though it doesn't matter to any of my classes or me, because all my classes are on Tuesdays and Thursdays. Monday's a holiday. What is going on? President's Day, right? No. President's Day? Yeah. Hi, Jennifer. Hi, Vanessa. Hi, Karina with a K, with two N's. So it's a very special Karina. Hi, Carly with the sheep. Hi, Karina with a K, but one N and different spelling, R-I. The two Karinas are right there. Hi, Drake. Drake sounds like an important figure from a sci-fi movie. Drake. Meet Mr. Drake. I have problems, okay? Forgive me. Roberto is connecting. I wish we could meet in person. Hopefully, I think I was listening to the radio on my way here. I think 35% down with people acting a little more responsibly. And I think the Christmas, those super spreader events are over right now. I think it's getting better. And probably the vaccine is working too. It's looking good. Hey, Michael. What time is it? 8 o'clock. Okay. No more chit chat. Any final words from anyone before we start? Before I start torturing you guys with chemistry? No? no words of wisdom or no words of lack of wisdom. I always make silly jokes. I think it's good for your health being silly. Who has
So,
joined?
I
Lisa?
just have a question. So our first quiz
Yes.
is going to be on our next class, correct? On Tuesday?
Yes. It's gonna be 500 questions and 2 hours long.
No, it's not.
It is. Why don't you guys believe me? I'm your professor. Whatever I say, you should believe it. No, I'm kidding. It's gonna be, I don't know, maybe 5, 6, 7, 8 questions. It's gonna be on Zoom, not on Zoom. What am I talking about? I need
Canvas?
better coffee. It's gonna be on Canvas. So you will probably toward the very end, maybe around 9 o'clock or maybe 5, 10 minutes to 9, I'll say, okay, we are done. Go to Zoom, go to Canvas, go to assignments, find the quiz, click on it. I'm going to make that available. It may not be available until then, so don't freak out if you don't see it's opening up. Then it's going to open up, and then you will go to question 1, whatever question, 4 answers, click the right answer, go through that, and then you're done.
Okay.
Okay. And it'll probably be available for, I don't know, 20 minutes.
Okay.
So you need to take it during that time. All right. Okay. Any other questions? Hi, Willis. Hi, Willis. And who else has joined since then? Vanessa. I think I have already gone through all your names. How many of you are here right now? 30? The number is dropping. Oh, okay. Let's go to the board. Let's switch camera. There you go. I think it's in HD. Nothing funny is happening. Okay, everything is looking good. Me stand up, trying to do some work. This is my morning workout. I'm going to close the blinds, drop the blinds. It's pretty hazy, not a very clear sky, clear day. Okay, I'll reduce the glare as much as I can. All right, let's go. I think I might need a new black pen. I have a pretty good source this time. All right, so we are, and it's recording. I'm just going to check. Yeah, I had completely forgotten to upload the video, the still pictures until this morning. So if you see that something is missing, shoot me a notification on Canvas or through my Fresno State, whatever works. Okay, so please remind me that something is missing. Can you please upload the pictures? Because with 3 classes, sometimes I get confused. Like I think I have done Chem 8. I think I uploaded the video and I thought that I was also done with the still pictures, but I was not. So my apology for that. Chem 8. And today is 2/11. I have no idea. 2/11. 2/11/21. Okay. We are talking about electronic configuration and we started getting into bonds. Okay. So I'm going to just write that down. Electronic configuration. And then the next item that we were talking about is bond. Okay. Bond angle, bond shape, other properties. You know what? I think I need a new red too. I have no idea what this pen is all about. I don't have a red. I'll just carry on with this for some time. Okay, that's that. Now, you may remember I'm going to just draw like a couple of elements right now and their electronic configurations, hydrogen and carbon. Then we'll go from there. then I'll introduce a new concept, okay? So hydrogen is okay, let's block it so that it doesn't come in our way. Okay, hydrogen is this. It's easy. Hydrogen is 1s1. So reminder, okay? If you are still not there yet, make sure you are there by the weekend. By Monday, you should be pretty comfortable with what we have covered so far. Otherwise, you will have trouble doing well in the quiz. That's hydrogen. That's its electronic configuration. Okay, carbon is 1s2, 2s2, 2p2, which looks like this: 1s2, 2s2, 2p2. Okay, this is ground state. GS, it goes into excited state. Okay, that means excited state. Okay, the star means that. And when it goes to excited state, this is what happens. I'm just going to ignore the 1s for now. It splits 2s and 2p so that it can bind with 4 hydrogens, because the bottom line is the molecule that it's going to produce between here and here, by combining 1 carbon with 4 hydrogens, it'll look like this: CH4. That's important because the smallest hydrocarbon is CH4 from experiment. Then we know if this is the correct thing, then that's not how carbon and hydrogen can combine to form methane. Okay, this molecule is called methane. Let me introduce the term hydrocarbon. So it's in the family, general family of hydrocarbon. Okay, I'm going to color code it so that you can see it better. Hydrocarbon family. Okay, it's in the hydrocarbon family because it's made out of hydrogen and carbon. That's it. Pretty straightforward. Because it has been found to have 1 part carbon and 4 parts hydrogen, this business has to happen. Okay, and we are skipping the core shell. Remember, there can be core and valence shells. Core shell is not important. Valence shell is important when it comes to bonding and making molecules. Okay, and once again, atomic number is the number of protons or electrons for a neutral atom. Whenever the number of electrons change, goes up or down, you have a chance to produce an anion or a cation. Okay, I'm trying to speak a little slower. Okay, so that's what happens. Now there is another concern. The new concern is, this is how I already showed you that this is how the different orbitals look like. I know that I'm not comfortable about talking about that. Okay, x-axis, y-axis, and z-axis. And the 2s orbital, you know what? Let me just color code it here so that it can be a little bit easier to see. So let's make this one 2px, 1 electron, 2py, 1 electron. I don't know how much color you can see in the video, but then hopefully in the still picture you can see it. 2pz, 1 electron, right? So the s orbital is here, 2s. Okay, that's this guy color coded, right? It's a spherical shape thing, okay, like a little ball. Here is the p orbital, 2px, okay. Here is the 2py orbital, that guy, that electron is here, and here is the pz orbital. And that's this electron. So the question now that arises, we already discussed it. If this is how carbon is binding with 4 electrons from 4 hydrogens, should all the carbon hydrogen bonds be of same length or different length? Should methane look like this? You know what? I have a better idea. Should the 4 bonds of methane look like this? Okay, so the hydrogen, let's put it in purple color. Hydrogen, that's the 1s orbital. This could be a question in quiz 1. I'll explain what's going on here, okay? Say A, answer B, and answer C. Okay, listen carefully. Treat this as a practice exam for quiz 1, okay? Like a practice question. 1 carbon is binding with 4 hydrogens, okay? Using these anchors. There is an electron in its S shell that looks like this, like a kind of small sphere. 1 electron is sitting in 2px orbital, which looks like a dumbbell, pretty long. 2py, pretty long, same length as this guy, but in different direction. 2pz is up and down along the z direction. So these orbitals are longer and bigger. This orbital is round and shorter, okay? So the black means S, and blue, green, and red means they are p orbitals. So my question is, what do you guys think? If you already know the correct answer, don't answer that correct answer. Don't go there. Based on what we have learned so far, okay? Imagine that this is how carbon is before that happens. So when that happens, the carbon is using 1 electron from here and 3 electrons from here and making 4 CH bonds. Do you think that methane molecule should have 1 short CH bond and 3 long CH bonds, or 1 long CH bond and 3 short CH bonds, or all equal length CH bonds? What's your gut feeling? Don't give me a smart answer if you already have read the book or if you already know the answer, okay? Based on this, which model fits this knowledge, this where we are right now, this information? A, B, or C? What's the correct answer based on that business? That's 2s orbital, that's 2px, 2py, and 2pz, color-coded. 2px, 2py, 2pz, and s orbital. S, px, py, pz. Which one makes most sense? Speak up. Don't write anything in the chat or give me any finger gesture because I'm not really looking at the screen.
Is it A?
Okay. So one answer is A. Anybody else?
I'm going with A too. I'm gonna go with A also.
Based on what you just gave us, I'd say A.
That's the way it is, right? So this is expected. This answer is expected based on this scenario. Okay? Now, this is where this is how science progresses. This is how chemistry, physics, everything progresses, because we know something today and tomorrow something else comes up and we look like idiots, right? I mean, that's not how scientists feel, but then science, you just make progress and then someone else takes over from there, makes more progress, and that's how science moves forward, right? So that's what it looks like if this is correct. But now give me, does anybody know if methane has this weird shape or methane has a different shape, either like B or either like C? What do you think is the real life scenario? If you take methane, and there are ways to measure actually its bonds by doing spectroscopy, by how electromagnetic radiation goes through methane and comes out, absorbs or something. And if there are two absorptions from the CH bond, one corresponding to a small bond and one corresponding to a long bond, then you can tell by analyzing how electromagnetic radiations like IR, radio waves, or even visible light, how these different electromagnetic radiations get absorbed or emitted by compounds, you can tell about their structure. You can have an insight about the molecule structure. So you can figure it out whether this is the right case, or that's the right scenario, or that's the right scenario. What is your gut feeling? Which one is the correct answer? I will tell you that this is not the correct answer. This is not how methane is. One short bond and three long bonds. What do you think is going on? Which one is the correct answer?
C?
C.
I feel like C is the right answer.
Yep, C is the correct answer. So C, that looks like a skull. C is when you experimentally figure out, this is expected. Like you build a battery and you expect it to last 4 hours to turn a turbine. But in real life, it can turn it for 3 hours or 5 hours, right? So in real life, so this is real number. Okay, this is real. This is the real business. So now the chemists have to go back and start scratching their skull, lose some hair, and come up with a new theory, right? This is how hypotheses and theories come about. There is nothing, no one like gets a, has a dream where like the goddess of chemical bonds comes to his or her dream or nightmare and says that, this is what's going on. There is something called hybridization, okay? No, you have an expectation based on your knowledge, but you realize that, oh shoot, something went wrong, it doesn't match. This is what I expect, but in reality, that's what is going on. So then we go back and say, something else is going on here. Something like this must be happening, right? So you kind of try to fit the experimental data by modifying your theories. That's exactly how science moves forward. There is nothing magic. You just see what's going on and then you try to explain, okay? That's what it is. So science is always changing. It's always dynamic, and we should always be very modest and humble. Humility is very important. So when I come across a scientist or a professor who is very arrogant, I don't like it, because I think humility is very, very important. You need to be very open to new ideas, and we suffer because my Alzheimer's disease project it has a lot of arrogant professors and scientists who are extremely rigid about their own ideas, and we get the short end of the stick all the time, because we are small timers from a small university and kind of flying against the wind. So that's a different story. That's my story of my life. You don't have to listen to that. So this being a smaller, lower energy orbital, and 3 equivalent higher energy orbitals. This is a little sketchy. You understand that there is something wrong with this model. We need to change the model. Something must be happening before carbon and hydrogen make methane, and before this business happens and it produces 4 identical, same length, same property CH bonds. So what's the great concept that the scientists came up with? Well, very simple. Don't let the word hybridization intimidate you. Okay, hybridization is very simple. So at this point, what happens is this excited state carbon hybridizes. I'll use a colloquial word. Hybridizes basically means mixes. 1 part S and 3 parts P. You dump it in a blender, like 1 part beef and 3 parts bean, and you make 4 parts of chili. Identical stuff. So this word, whenever you are feeling uncomfortable with the word hybridizes, hybrid car, an ICE engine, internal combustion engine, coupled with a battery. That's what it means. The 2 things working together. So hybridizes means you take this and that, put it in, mix it up, and you end up making 4 orbitals that are mixed orbitals or hybrid orbitals. Think about the word mixed. It'll probably make more sense to you. Okay. So this is nothing but, I'm going to put it in black. This means, this is basically meaning that it's mixes. Think about the word mixing. Okay. It mixes and produces. From here, you produce 4 orbitals of equal property. We don't draw that box anymore, because whenever we draw the box, like a cubical box, it represents a pure orbital. This means pure orbital. These lines mean they're mixed or hybrid orbitals. Now, the black and the blue and the green and the red, those 4 electrons in those 4 orbitals, pure orbitals, they're now in hybrid orbitals. This is hybrid. And they have identical properties. Okay? Because I have drawn them at the same level, horizontal level, that means they're at same energy. This is energy. If I drew them like a step, that doesn't serve any purpose. They are at identical energy, they're hybrid, and there is a name for this sort of mixing, not missing, this sort of mixing. What do we call this hybridization? We are taking 1s and 3 p's. So we should have called it S1P3, but we don't write the 1. We call it sp3 hybridization. Important, you need to keep that in your hard drive. This is called sp3 hybridization. An uppercase S, a lowercase p, and a 3. sp3 hybridization. Okay, because we are mixing 1s with 3 p's. It's just like making chili, from 1 part beef and 3 parts bean. Mix it up and you put it in 4 bowls, and each bowl has 1 part beef and 3 part chili. And if you're feeding 4 kids in the house, and they're happy because they want identical food with each other. They don't want somebody to get more beef and no chili, no bean, and 3 other kids to have 3 bowls of bean. That's not what they want. There's going to be a fight breaking out between the kids at night. So you just mix it up and make chili, and they're all happy because nobody got anything different, right? So this is what happens, and this is what hybridization means. Hybridization doesn't go very well with my students historically, traditionally in the past. So I'm going to pause for like 15 seconds and let you guys kind of absorb it, what we just talked about. Make sure you understand what's going on here. If you ask me any questions, if you have any questions. I'm just going to write down, you guys continue to think about it. Okay, so this is just the orbital, and then this is the molecule. I just added a line. This is how carbon is born, ground state. Okay, if I ask you to write down the electronic configuration in the exam, this should be your answer. 1s to 2s to 2p2. Remember, this is important. Don't make a mistake by not paying attention. Ground state representation is this. Excited state representation is different. Excited state, if I just have to write it down, it will be 1s2, 2s1, 2p3. Pay attention to that, please, because this could cost you some points. If I ask you ground state carbon, this is what you write. If I ask you excited state carbon, this is what you write. Make sense? Because one of these s electrons has jumped into the p orbital. This guy has jumped here. Now it's here, sitting here. So this is what that is, and that's that. After that, it's not good enough based on the structure and the bond property of methane. We figured out that this is not how methane looks like, even though we expected it to look like that. They're all equivalent. Because they're all equivalent, we came up with a theory, and it's called hybridization theory. What does it mean? They just mix up and they produce 4 identical orbitals, and they're called sp3 hybridization or hybrid orbitals. In this case, the methane molecule has already happened. So these horizontal lines are now representing 1 CH bond. 1 electron from hybrid orbital and 1 electron from 1 hydrogen. Hydrogen 1, hydrogen 2, hydrogen 3, and hydrogen 4. This is representing 1 CH4 molecule. I think after this, I'm going to erase the board and start discussing the shape of the molecule. One second, excuse me, I'm going to block the camera. There you go.
Dr. Mitra, I have a
Very
question for you.
important. Sorry. question?
Yeah, I have a question for you. So
Please.
on the exam or the quiz, there are three. So I'm trying to clarify. There are three ways you could ask us to represent carbon. For example, so that would be like in the ground state using the box model, then in the hybrid state using the box model, or sorry, in the ground state and the excited state. Then you could ask us also in the hybrid state, correct?
Yes, in principle, but when I ask about the hybridization or hybrid state, it'll be more direct. Maybe toward the end, maybe at around maybe 9:05 today, somebody remind me, not so that I can stop lecturing, and maybe I can show some model questions, sample questions, like how I might be able to frame it. Why don't you remind me? And you are Devin. Devin, you remind me around little past 9. Let me lecture for another half an hour, then we can work out some, just what could the question look like. That'll probably,
Sure.
That'll probably
That would
help.
help a lot. Thanks.
Absolutely. Good idea. Thank you for speaking up. Appreciate it. I'm loving this class. I think something different this spring. Fall was, let's not talk about fall. I have PTSD from fall. Seriously. Something just didn't click, or I was just a horrible instructor in fall. Something, maybe there was some dark force working on in here in my office. Any questions? This is very important, and you guys get confused. So I am begging you, I'm not urging you, I'm begging you to watch the videos, read the book, find out information. If my videos are not good enough for you, find the resources, talk to each other, talk to me. I can set up some office hours. No one has asked for office hours yet. That's a little scary because sometimes you guys freak out at the end, like in end of April, you will be like, Dr. Maitra, I need help. Don't do that. So figure this out. Figure out what's going on. It's not complicated, but you cannot just not think about it for like 2 more days. And Monday night, you start thinking about hybridization and you're like, oh, I have no idea what's going on here. What is hybridization? What's going on? Ground state, excited state. Why does it have to mix? What does hybridization mean? You might be really freaking out if you don't do any reviewing until, like on a regular basis. Please, I might be talking like your grandpa, lecturing you, but then that's my job. That's how I get paid for. Any other questions? This is good. You got it? I'm a little nervous, as you can see, that I'm probably pausing more than I usually do, because this is not an easy concept for your everyday life. Well, if you make chili from 1 part beef and 3 parts bean, you will be thinking about hybridization. You will be thinking about my class every time you make chili. I don't know what the recipe is. What's the ratio of beef and bean? It depends on your resources, probably. If you have too much beef and 1 can of beef, then it will be 3 parts beef and 1 part chili, or 1 part bean. Are we good? You guys are feeling okay, comfortable? I'm little concerned at this point. Tell me that there is nothing to worry about for me. You're good. Give me a thumbs up. I'm looking at the screen. Feeling okay? All right. That makes me feel better. Okay. Thank you. All right. So let me erase the board. I'm erasing.
How many questions will be on the quiz?
About 52.
Doctor? How many?
I like 52.
52?
Yeah. Ray, do you
You're
think
messing with me, huh, right?
I don't like that question.
Why?
Because why should you be worried about the number of questions? 52 is a bogus number. I was just messing.
I know, that didn't sound right to me.
Yeah, that didn't.
It sounded like a lot.
That shouldn't sound right. You cannot answer 52 questions in like 15 minutes. That sounds like a Geico ad. 52 questions in 15 minutes could save you $50 of agony. No, not 52 questions. I'm not going to tell you how many questions. You should be learning the material and not worry about number of questions.
Okay.
Okay. I don't know, maybe 5, 6, 7, 8, something like that. Multiple choice. Each question will carry like 2 points. So it could be 10 points total quiz are 14 points, 16 points, something like that. So you will have plenty of time. If you're completely, if somebody is totally clueless, you will be like scrambling all over. It's going to be open book, open internet, go find your answer. But if you haven't studied, you won't find your answer, okay? Because I'll make you guys think. So you need to really know what's going on. You can even discuss with each other. I don't care. For quiz one, it's allowed. Let's put it that way. You can talk to each other. Find out the answer. I want you to learn, and maybe that first quiz will be a wake up call for you. Okay, so figure it out. Learn the basic organic chemistry. That's my whole idea. You know, learning can be done in so many different ways. Sometimes the group project, you know, you might say, oh, when you're working on a group project, it's everybody's cheating from each other. No, not really, but you learn, right? Our son is in a club in his college, and they're working together. Like they have divisions and they're taking care of each other, and they're different people are learning everything. Are they cheating? Not really. But when you are really cheating, like copying from somebody else's answers, that's not good. That means you're not earning your points, you're not earning your grade. But if you discuss and figure things out, that's what Hackpack is supposed to do. I still haven't gone back to it yet and checked it out. My life has just started to become a little bit easier, so I'm going to start paying attention to all of that now, hopefully soon. Until last Sunday, it was pretty hectic, but it's much better now. Okay, so now, what should be the shape of this molecule? That's the next question. What should be the shape of this molecule? And I can almost guarantee that most of you have played with magnets. When you're a kid, or even now, I don't mind playing with magnets even now, or maybe playing some pranks with people. Talking about magnets. Magnets can be really cool. It's like an invisible force, right? It's very, very cool, very interesting. So this molecule, if you think about this molecule, so shape of a molecule. Okay, that's what we are discussing right now. We are into that area, shape of a molecule. So this molecule is CH4. Okay, all identical bonds, pretty much. Okay, remember something here. Okay, Lewis dot structure of methane, it comes kind of handy. Even though Lewis dot structure does not represent its shape, I have an ambitious idea today. After we discuss its shape, I'm going to tell you like how to draw methane in 3 dimensions. Normally, we're not supposed to do that at this point, but I'll do it. Okay. Remember something very basic. You know this answer. It's not very complicated. When you have 2 positive charges, right? One positive and another positive. 2 ions, 2 cations. Let's say 2 sodium ions. Okay, are they going to attract each other, or are they going to repel each other? What do you think?
Repel.
Repel. Similarly, 2 electrons. Don't think about the atoms and stuff like that, how the electrons are spinning around. But if you could bring 2 electrons close to each other, both are negative, do you think they will repel or they will attract?
The
Repel.
Repel, right? So if you look at the bonds, okay, bunch of electrons, 8 electrons in a very close area, okay? So it's kind of like, I would love to have this model. I don't have it. I should Google or look at Amazon if they have it. you know what bar magnets are, right? Most of the times we see the round, flat, like disc-like magnets, right? There are also like horseshoe-shaped magnets. If one of you guys, or if you guys have played with electronics, and if you have done some home projects or made a little radio or intercom or something, my brother and I used to do that when we were kids. And each part used to be very expensive. We were born in very middle class Indian family. My dad could not even afford a car, so we had a bicycle. So anyway, so we had to buy like a transformer in January, then bunch of resistors in February. So it was almost like a year project. And at the end of the annual exam, my brother would have collect all the parts for building a radio, like a simple radio, and the diagrams would be actually published in a young like teenagers magazine, like a monthly magazine, and they would talk about the different circuits and stuff, and so that kids can engage themselves in building some science projects. So if you take a bar magnet, I bet you guys have seen bar magnets, right? North Pole and South Pole. If you tie a string to the bar magnet, and if that's the South Pole, that direction, the bar magnet will basically swing back and like swing back and forth and eventually line up with North and South Pole, right? So if you could take some kind of a device, let's say that if you could devise like a plastic thingy with a flexible like four-pointed plastic device, like a little contraption, where you could stick 4 bar magnets, right? Like a little opening here, like a little cylindrical opening here, and another one, and four points, and they're all flexible. Think about it that way. It could be either some kind of a gadget, or it could be just connected with some soft plastic. Okay. Then what you do is you stick 4 bar magnets. Okay, 4 bar magnets, and let's say these are the 4 bar magnets, and let's say this is the north end. Blue means north. Okay, so you have basically attached 4 bar magnets to the central flexible joint, and all these ends that are close to the center, they're north. North, south, north, south, north, south, and north, south. They're going to repel each other, right? They're going to repel like crazy. The south poles will repel and the north poles will repel. Same thing happens here, and they're repelling, okay? There is tremendous repulsion. And this is called valence shell electron pair repulsion. When you read and you have to memorize it, it makes no sense. But if you understand, then you know what we're talking about. It's very simple. So like the bar magnets, this is south, they will be repelling each other. Okay. Similarly here, this is called valence shell, because all these dudes are sitting in the valence shell. We don't care about the core shell. That's why it's called valence shell electron, not just one electron pair. So it makes sense to you. You should not have to memorize it. You should just remember it by heart. Okay. Valence shell electron pair. Simple, very simple. Describe the way it happened. Okay. Repulsion. And this whole thing is called theory. Valence shell electron pair repulsion theory. So it's also called VSEPR theory. Okay, what is this VSEPR theory telling you? It's basically dictating the shape. So when you have four little sticks attached to itself, and they're repelling each other, how should they be lining up? Should they look like a little, like a pyramid, like this? Should they be planar? Is this how they can be farthest away from each other? Or it should adopt a different shape? Does anybody know what shape they're going to be adopting? And it's a T word.
Tetrahedron.
Tetrahedron. They're going to take a shape of a tetrahedron. What does it look like? I'm going to show you what it looks like, and then I'll explain how exactly you can basically perceive it. Tetrahedron is this. Basically, this is just geometry. Tetrahedron is like this. This is a tetrahedron. Okay, I'll explain what tetrahedron is. Okay, so the shape, this theory is actually dictating the shape of a molecule. Shape of a molecule. Okay, and this particular guy is going to look like a tetrahedron. Tetrahedron or tetrahedral. Tetrahedron is the noun. Tetrahedron, this shape is called tetrahedron. Sometimes we will use the word tetrahedral. That's the adjective. You can say it has a tetrahedral shape, but it's a tetrahedron. Okay, what does it look like? I'll explain, and hopefully this will make sense to you. Okay, I'll just explain. I love geometry. I was not a big calculus fan, but I love geometry, and hopefully that can help. Okay, imagine a cube. I'm going to use a light color. Imagine a big cube. Okay, that's a cube. These are the lines in the back that you cannot see from the front. It's a cube. Got it? Imagine the carbon is in the center of the cube, right here. Carbon is in the center. Make sense? Two hydrogens are across either here and here or here and here. Let's use which one will be easier for me to draw. Let's use these two corners. Okay, let's put this hydrogens, one here and one here. That's two hydrogens. So if this is a box, two hydrogens are on the two corners, like the diagonally, like along the diagonal, okay, of that square. Okay, this is the diagonal, right? The two hydrogens are there and there. These two guys are down on the bottom of the cube, but perpendicular to the line that joins the hydrogens on the top. Okay, they're perpendicular. Okay, so these two guys, those two guys cannot be here and here. They have to be here and here. Okay, that's a tetrahedron. In the center, there is one bond here. Okay, I'm going to draw the bonds with purple color. So this bond is kind of parallel to the board. This bond is sort of parallel to the board. This bond is kind of coming toward you. How do we show that? With a wedge. Because, you know, objects close to you are bigger. As the bond is kind of tapering off further away into the horizon, you see it smaller. So when you see a wedge coming toward you, that means it's sticking out of the plane of the screen or the board or your paper. That means it's out. Wedge means out. Dashed line means going further away. Okay, so this bond is actually dashed. That means it's going further away in the back. Okay, I'm going to just circle them to make them a little more visible. So this is when you see a cube, the central element is in the middle, and two are here and two are there, down there, or opposite way, it doesn't matter. They just have to be perpendicular to each other. That's a tetrahedron. This is a tetrahedron. Okay, if you do some simple geometry, not complicated, even I think I can figure it out with my forgotten math and geometry. I still have nightmares about some calculus stuff. I can't share that task with you. It's not very glorious. Okay, the angle between hydrogen, carbon, hydrogen, or hydrogen, carbon, hydrogen, these angles, anybody remembers that angle? I'll show you that. I'll give you that. We'll throw some numbers. So this angle, or this angle, or this angle, or this angle. Okay, I'll say one answer is 90. One answer is 45 degrees, 90 degrees, 109.5 degrees, 120 degrees, or 180 degrees. Which number makes more sense to you?
109.5.
Yes. That's the right answer. So all the angles of a tetrahedron are 109.5. Excuse me. 109.5 degrees. We still have 6 minutes to go to 9. Okay. So this is what methane looks like. So when you have methane, this is what it looks like. And I told you that I'm going to teach you something that is usually not taught at this point. So now you know when you draw methane, okay, how many different ways you can send the shape or the name of the molecule methane, the smallest hydrocarbon, to your friend. Okay, you can text your friend. You can say, you know what, Shantanu or Dr. Maitra is talking about methane. When you hear methane, you think about cows. You think about I'm not going to talk about that. That's a long story. No distraction. It's a flammable gas. It's a stinky gas. Blah 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 blah. So that's what you think about. Okay. Or you can say, oh, you know what? Dr. Maitra was talking about methane. Okay. What does it show? What does it tell your friend? It shows the formula. So it must be a gas. If you tell him or her that it's a gas, methane, or she already knows 1 part carbon, 4 part hydrogen. Okay, it still doesn't give you an idea about what it looks like. So after Chem 8, when you hear methane, I want you to think about the image that flashes in your mind it should be a three-dimensional methane molecule. That should be your punishment. For the rest of your life, whenever you hear someone utters the name of a molecule, you should be having images of molecules made out of different elements. Okay, that's what Chem8 is supposed to do to you for the rest of your life. So you can think about that, or you can think about if you can send your friend a text, an image. You can send her an image that looks like this. It's still not good because it shows that there are 4 equivalent bonds. It still doesn't show exactly how methane looks like in 3D. In 3D, it looks like this. So this is a 2D representation. This is a 2D image. How does a 3D image look like? This is how we do the 3D image. This is something that we will need later on, but I want you to learn it right now while we are in the topic. Okay. What does methane look like in 3D? This is what it looks like in 3D. In 3 dimension, okay, methane looks like this. Carbon, 1 bond is drawn up here. Solid line means on the whiteboard. Okay, you know what? Sure, blue is good. Okay, solid line means on the whiteboard. Another slanted line, kind of like, I don't know, maybe 45 degrees. So there is a hydrogen here. There is a hydrogen here. You're done with the solid lines. The next line is a wedge. Hydrogen here, and then you have a dashed line, a hydrogen here. Okay, and this is how you represent a tetrahedral. Tetrahedron. So let me make a model. Okay, that's the central part, carbon, and these are the carbon-hydrogen bonds. This is a perfect tetrahedral. How did we draw it here? We drew it this way. Central carbon, hydrogen, hydrogen on the 2 corners, 1 hydrogen coming toward you, right? Coming toward you, this is the wedge, and that's the dashed line. It doesn't matter how you draw the molecule. I'm trying to hold it so that you can see it in the white background. On the 2 diagonal corners up there, right? Carbon is in the middle. And this is the wedge coming toward you. And that's the dashed line going away from you. This is when you should seriously think about spending maybe $12.50 or whatever to buy the cheapest molecular model. Make a model and start playing with it. You don't even need model. You know, I had a student who is a physician right now. You might come across him somewhere. He was a resident in Visalia, Coya Delta, Robert Granata. Okay, you know how when he was taking organic chemistry course from me, how he made his model? He took an old eraser and he took 4 color pins, like the pins, and he stuck it on that little eraser. So his eraser was the central part, and he stuck the pins in the tetrahedral shape. That was his model. Sometimes I have seen my students making origami with piece of paper, making a square box and coloring the corners as if they're hydrogen or chlorine or whatever. Okay, so you can be innovative if you don't want to spend the money. But if you spend like, I think the cheapest model I saw was $12 and some cents on eBay, not on Amazon. Okay, so this is tetrahedral. This is what tetrahedral looks like. You can hold it this way, like three landing gear and 1 antenna. You can hold it. It doesn't matter how you show it. Okay, or you can show it the way that's the kind of like the convention. Okay, the way I have drawn it is like this. That bond is on the whiteboard. Hold on. If this is the whiteboard, you know what? Let's do this. if this is the whiteboard, okay, one bond is up, one bond is kind of slanted down here. Up and down, right? Up, vertically up, this is like an angle, whatever, 35 degrees, 30 degrees angle, okay, down here. This guy is the wedge out, and this guy on the back is the dashed line. Make sense? Is everyone comfortable? This is how methane molecule looks like. From now onwards, whenever you hear the word methane, this is what should be flashing in your mind. Two hydrogens, either this way. You can hold it anyway. You can draw it this way too. I can draw it all kinds of possible ways. I can draw it this way. Two hydrogens are on the plane. One is out and one is in. Doesn't matter how you draw it. I'm just saying that this is the convention. Or I could draw the bottom bonds on the plane, and the up bonds are out and in. It doesn't matter. The molecule doesn't change how I draw it. It's just like observing my mouse from the side at an angle, front view, top view, bottom view, upside down side view, upside down back view, upside down front view. You know, the mouse doesn't change. The molecule doesn't change just because I'm looking at it pointed like this. I mean, I could just say that, oh, methane looks like this. And one hydrogen right here. You can argue if you draw it that way and say, Dr. Mitra, that's how I visualize methane, like this. Like this is the propeller, this is the axle, and this is how the propeller turns. Yeah, so it's your imagination, but you know, if you don't show me the fourth hydrogen, you might lose 25% points there. If there are 4 points, and if you show only 3 hydrogens, I might give you 3 out of 4. That's the only caveat. Does it make sense? We can now discuss a little bit of, we can do a little bit of review, questions and stuff. Okay. Is it sinking well? Is it sitting well with you? Any questions? Before I forget, let me take a snap. Then I'll give you guys a little more time to think about it. I'm going to block the camera. My apology. Yeah? Are we good?
Yeah.
Okay, sounds good. So why not we raise the board, make all the things available as soon as I can. I may have to run some errands. So if you don't see the video and the still pictures up on the uploaded, you can shoot me an email, message, send me a message or something. I should do it sooner than later because I think you guys need every information for the quiz. Let's do a little quick review, maybe for 11 minutes. I'll show you like what kind of questions. Don't think that what I discussed now for 10 minutes is everything that you need to study. No, this is just a representation of what it might look like. Okay, so make sure that you don't get stuck up on this concept that, oh, this is all I need to know to do well in the quiz. You need to study more than this. This is just a sample. This is just a small sample. By the way, I know that we are still kind of young into the semester, pretty early, but if you ever have any questions about, I don't know, medical school, pharmacy school, VA school, or other things, or career, if you want my opinion, I would be more than happy to like sit down and talk to you about whatever you want to discuss. So don't, I think what we are trying to tell our son to go and talk to his advisors to figure out what he wants to do in future, I think I'm going to say the same thing to you. That don't feel hesitant or inhibited. I mean, I'll be super happy. I'm usually pretty, I'm always interested to know what your plans are. Are you going in the right direction? Is that what you want to do? Are you just trying to please your parents by, doing what they want you to do? That happens a lot with certain demographics. One question that you might be wondering, I mean, a sample question. Which element has the following electronic configuration? Okay. Just a sample. I'm going to just draw like a bunch of them and ask you what it is. Okay. Let's say question number 1 could be 1s2, 2s2. Answer 1, hydrogen. Answer B, helium. Answer C, beryllium. Answer D, boron. Which one is the correct answer?
C.
That's too fast. Good job. How about this? Could be, I don't know, 1s2, 2s2, 2p5. Nitrogen, boron, carbon, fluorine.
D.
Someone is on fire. How about this? 1s2, 2s2, 2p6, 3s1. This is a tough one. You haven't really seen, and let me just see how many of you remember. Let's say neon, lithium, sodium,
C.
argon. That's I'm not going to upload this on your it's not going to be a picture, so this is just a review. Okay. You want to take a screenshot or something, you can do that, or take note of it. You need to really understand it. There is no point, like, I will make sure that I don't ask the same identical questions in the quiz. So memorizing it will not work. You need to really know it by heart. Got it? What if I say that's one example. Another example could be if I draw this. Remember that it's going to be one color. I might put colors too.
Boron?
I haven't even asked the question.
Oh, my bad.
No, it is boron. Yeah. So I can say, what is it? Ray is on fire. Okay. Yeah, it's boron. Ready? This could be a tough, a little difficult one. Let's use the same style. Okay. And I might say this is gray, quite. This is lithium. This is helium. This is lithium plus, or this is I don't know, carbon. What is it?
C?
C.
Can you guys let others try to answer so that I'm not blamed for having my being partial? Okay, yeah, see. So you guys great, keep your mouth shut. 1, 2, 3, 4, 5, 6, 7, 8, 9. That looks like a garden. This is where you're supposed to be planting the succulents and then the yeah, I know that it's probably you're probably having an itch, some of you, to answer, but just resist it so that everybody can think. Okay. What is it? I'm not going to write down. Let me see how many of you can think about it.
Fluorine with a -1 charge.
I agree.
You agree? Okay. Both of you stay quiet for some time. Thank you. Anybody wants to think about it? What is it? How do you know? How do you determine what element it is? What's your first step? This might be messed up, but the nucleus doesn't change. That's where you get your atomic number. Atomic number. You get your atomic number from here. Count 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 means what?
Protons.
Sorry,
Protons.
it's a proton, but 9 means which element?
Fluorine.
Chlorine.
Fluorine.
Fluorine, F or C?
F.
F.
9 means F. Good job so far. Count the electrons. 2, 5, 7, 8, 9, 10. Number of electron is 10. Oops, it's not 9. That means what?
Anion? Anion, or what are you, how do you say it?
An. Don't say anion.
How do you pronounce it? I keep saying anion.
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 Anion. I know that that's correct pronunciation, even though I have funny pronunciations being an Indian. Spent 26 years in India before I came to the US. Yeah, so I can't undo my past. My tongue has been trained in a certain way. So you guys got it? Stare at the board for some time. Just make sure that you're okay with this. Okay, I can ask another question. So this is boron. This is lithium plus, and this is fluorine minus. Okay. Which of the 3 species does not have core shell? That could be a question. Which one does not have core shell?
Can I guess on this one? Boron?
Which one has only valence shell? You're thinking too much. You're making things unnecessarily complicated. Anybody else? Just
Lithium.
Sorry?
Lithium.
Yeah, because this is valence. This is valence. This is valence. This is core. No core, just one. This is core. Got it? Make sense? This guy doesn't have any core, no core. Make sense? Okay. Again, what else can we talk about here? If I say draw that could be another question. We have almost out of time. Electronic configuration of F minus. How do you do it? Help me. What's the electronic configuration of F minus? If you have to write it down, 1s blah blah blah, 2s blah blah blah, something like that. Okay, help me. 1s,
2.
10,
Plus 2.
then
P.
5.
five.
Yes.
F minus. It's the ionic fluorine, not neutral fluorine.
2p6.
It's F minus 1, 2, 3, 4, 5, 6, 7, 8. That's F minus. It snatched an electron from some dude, some poor metal like lithium or sodium or potassium. Okay. This could be a very, very common mistake. You know what not to do. For F minus, you need to add an electron to its normal number of electrons. You know, this sort of questions, then we can talk about hybridization and stuff. I think you can study the rest, but this is how the questions might look like. Okay. All right, people, go run around the building for some time and drink a cup of coffee. Chase the neighbor's dogs. All right. Have a good day and have a good weekend. Don't go to school on Monday. It's a holiday. President's Day and Students' Day. Okay. I declare it as Students' Day. Take care. Have a good weekend. See you guys on Tuesday.
Thank you.
Bye.
Thank you.
Bye. Yeah, no problem.
Thank you.
Take care. Okay. Bye.